Hey everyone, welcome to CrickStacks. Today we're going to be tackling a popular coding problem that's often asked in technical interviews. We're going to be checking if an integer is a palindrome. A palindrome is a number that reads the same forward and backwards. So, for example, here the -1 to 1 does not read the same forward and backward. 1 to 1 does. We check it, it's a palindrome. 1, 2, 3. It's not the same. If we check it, it's not a palindrome. Same thing with the initial one we checked. This -1 to 1 is not a palindrome because it doesn't read the same forward and backward. So this video will start with a straightforward approach of converting a number to a string and then reversing it. And then we'll move on to a more efficient solution that will be optimized for time and space complexity. So let's dive in. Let me show you my terminal and my code. So here, I'm going to be writing the code, and then over here, I'm going to be running the code. So let's start by creating the function to check if a number is a palindrome. X, I'm going to be passing it the number. So one thing we have to know first is that, palindromes cannot be negative numbers. Also, we have to have knowledge that when you pass a string or a number, you need to first convert it to a string in order to reverse it. Because here, let me show you. If you go here to Mozilla and check for the prototypes, the functions that a certain object can use, you'll see that to reverse a string, to use a reverse string, it only works on arrays, not on strings or numbers. But in order to split a number or a string, the number you cannot be used for that. I wish I could better explain it. So here, the number prototype has these methods, right? To fix, locale. So that's what you can do with a number. You can convert it to a string, and then once we convert it to a string, we can split it into an array, into its individual parts. And once we have it in an array, then we can reverse it. So let me go back to the code now. Now that we know that, first we'll need to check if the number we're passing is a negative number. So if it's less than 0, we're just going to return false. It's not a palindrome. And then the next one, in order for us to be able to do all the manipulation, first we have to convert the number, the integer, to a string. So x to string. And then once we have it in a string, we can split it, reverse it, and check. So here we would just do a return, and then we would check if the string that we have is equal to the string split, converting it into its individual parts, which will create an array. Then we can use the reverse function prototype to reverse the array. And then we got to use the join to join everything back into a string. So here, let me expand this. So now here, this string, which would be, let's say 1 to 1, we're going to split the 1 to 1 into an array, and then we're going to reverse that array, and then we're going to join it back into a string. So here, let's just do a console log. We're going to be calling the is palindrome, and then we're going to be passing it the integer 1 to 1. Right? So let's close this right here. So now we can call that function or that file. So we'll use node is it's not is palindrome. I just call the file palindrome.js. So I'm going to be running that. This is true. So here we can check 1, 2, 3, save it, run it, and that is false. It's not a palindrome. And then we'll do the same for a negative number, negative 1, 2, 1. Save it, run it. It's not a palindrome. So this is a simple way to check if an integer is a palindrome. We first have to convert it to a string, then we have to split that string to convert it into an array, then we have to reverse it, and then we have to convert it back into a string to check the two strings to see if both of them are equal. So the time complexity for this is it's linear, right? It's just iterating through all the digits of x, which is O of n, and then it's converting to a string, reversing it, making the linear time complexity. And then the space complexity is O of n because we're iterating through all the extra space used to store the string representation of the number. So this approach is simple and easy to understand, but it requires extra space to store the string and then reverse it, which can be inefficient for very large numbers. So the second approach will be using a mathematical approach where we avoid using the string manipulation altogether, and instead we'll reverse half of the digits in the number and check if they match the other half. Okay, so let's start doing that. We'll just comment this out. I wonder if I can make it smaller. You can still read it. You can see more of this. There we go. You can still see that. Okay, so here, first things, we're gonna check if x is less than 0. If it's a negative number, we know that it's not gonna be a palindrome. And then, or also, if the number ends in 0, it's not going to be a palindrome because let me just show you here on this one. Go back to the example. So here, if it ends in 0, doesn't matter what it is, it's never going to be a palindrome because the numbers will not match, right? So let me go back to the code. So then how do we check if the ending number is a 0? We will say x divided by, check for the remainder. So we use the modulus 10 divided by 10 equals to 0. Oops, equals to 0. We know that the ending number is 0. So that would not be a palindrome unless the number itself is a 0, which 0 is. So, and the number is not equals to 0. So here we're checking both of these. We're dividing by 10. So like 230 divided by 10 would be 23. The remainder would be 3. So this would not compute to 0. So we can continue. But if not, then we would return false. Okay. So then as long as the number is not negative, it doesn't end in 0. But if it's 0, it's okay. Then we continue. So now we're going to do reversed half equals 0. Here we're going to iterate through while x is greater than reversed half. We're going to get the last digit of x and then add it to the reversed half. So reversed half will be reversed half times 10 plus x modulus 10. Okay, so now that we're here, we're going to remove the last digit from x. So x will now be math floor, and we're going to do x divided by 10. So that will give us the last digit removed. Now math floor takes a number like let's say let's do 121 divided by 10 is 120. So having like a brain fart here. Okay, so like 121 divided by 10 is 12.1, but math floor takes the number into a whole number and removes the decimals. So now the x will be 12. And it's going to continue doing that until it gets to um, x being greater than the reversed half. So we'll go through that right now, one by one. So now we have to return the check. So for even numbers like uh, 1, 2, 2, 1, the numbers would be 12 equals 12. But for odd numbers that we're passing, we're going to have a middle number. So we're going to have to check for both of those. So return if x equals to the reversed half. If the number is even, then they're going to equal. Or if x, we're going to do this check again right here. The math, yeah, we'll just do that check. Math, if x equals, oops, math floor, but instead of the x, it's the reversed half, then it's going to be true. Let's save that, run it. Where do I have the error? Reversed, not equal to. Up here is not equal to 0. Oh, let me check it. Gotcha. I see it. I'm not checking anything. X is not equal to. Save that. So there it is, true. Let me go back down here. 3. That's false. Let's do a negative number. Negative. Run it. False. So basically, it's just iterating until x is greater than the reverse half, and then we're comparing it down here to see if they're equal. This one has a time complexity of O log 10 n, where n is a value of x, right? We only process half the digits. So the number of iterations depend on the number of digits, which is logarithmic. But for very large numbers too, we're only going to use half of them. And then for the space complexity, it's just O1 because we're using x in reversed half, and we're not adding any additional space. This approach is more energy space efficient because it avoids string conversion, and then it only stores a few variables like x and reverse half. Now, some of the key assumptions that we need to consider for these methods and interviews in real-world applications is that negative numbers that have a negative sign cannot be palindromes. Numbers ending in 0 cannot be palindromes. And then single-digit numbers. Any single-digit number is a palindrome as it reads the same forward and backwards. So to recap, a simple conversion approach uses the manipulation, the first one we used, to check if the number is a palindrome. It's easy to implement and uses additional space. The more efficient way, the mathematical approach, reverses only half of the digits, saving the space and making it ideal for larger numbers. Uh, in interviews, you're going to always consider the trade-offs between simplicity and efficiency. The mathematical approach is more optimized, but if the space isn't a concern, then the string conversion is still a valid choice. I think they're just going to be checking to see if you know how to do both and understand the space and time complexity of it. So yeah, those are the two, and then you can. Let's see. I'll have this up in my website. I'll push this up there, but here you can play around with it. This is going to be blog or I want to have it on my website, but maybe I'll switch it up to another one. I have the blog, the in-depth, so you can come here and read how to do this. I have all the code example, so feel free to come and check this out. I'll put all this on the video. Let's see, what else is there? I think that's it. So yeah, thanks for watching. I hope this helped. Different ways to solve the palindrome. Now, if you enjoy this, like and subscribe. It's going to help me. I'm going to be putting more of this up there. So yeah, I'll talk to you guys later.